champs of Examsnet, welcome to the question series of Examsnet. I hope this series of detailed explanation is helping you a lot. So in today's session we are going to discuss NEET 2023 physics paper which has 50 questions. So let's start with the section A. Okay. First question is from the chapter Systems of Particles and Rotational Motion, and the question is the ratio of radius of gyration of solid sphere of mass m and radius r about its own axis to the radius of gyration of thin hollow sphere of same mass and radius about its own axis is. Okay, so let's see. For solid sphere radius of gyration about its own axis is equal to under root 2 by 5r. Okay, whereas for hollow sphere, the radius of gyration about its own axis is under root 2 by 3r. Okay, so we simply have to find the ratio of these, right? So the ratio will be equal to under root 2 by 5r upon under root 2 by 3r. Okay, r will be cancelled, so it can be written like this: under root 2 by 5 into under root 3 by 2. Okay, so here again root 2 will be cancelled. What is left here? Under root 3 by 5. Okay, so the ratio will be root 2 is to root 5. Okay, because 3 and 5 are under roots. Okay, so this will be the ratio. Here in options we have 5 is to 3, 2 is to 5, 5 is to 2, 3 is to 5, but not root 3 is to root 5. So none of them will be the correct answer. Okay, so option E is the correct answer. Question number 2 is from the chapter Dual Nature of Radiation and Matter, and the question is the work functions of cesium, potassium and sodium are 2.14 electron volt, 2.30 electron volt and 2.75 electron volt respectively. If incident electromagnetic radiation has incident energy of 2.2 electron volt, which of these photosensitive surfaces may emit photoelectrons? Okay, options are both sodium and potassium only, sodium only or cesium only. Okay, so we should know in what condition the photoelectrons will be emitted. Okay, so for emission of photoelectrons, we know that the incident energy should be more than the work function, right? Work function. So if we talk about cesium, so for cesium here the work function is 2.14. Incident energy is what? 2.2 electron volt. This is incident energy and that is more than 2.14. Okay, 2.14 is the work function here. Okay, work function, and 2.2 is incident energy. So yes, here energy is more than the work function, so it will emit photoelectrons. Now let's see for the second one, that is potassium. So for potassium, energy is 2.2 volt, but its work function is 2.3 electron volt, right? 2.3 electron volt. This is the work function and this is energy. So here energy is not more than the work function, so this will not emit the photoelectrons, right? In the third case, that is sodium. Again, what is energy? Energy is 2.2 electron volt and the work function is 2.75. 2.75 electron volt. Again, here the energy is less than the work function. So in this case also, if photoelectrons will not be emitted. So the only case where photoelectrons will be emitted is the first one, that is in cesium. So only cesium, that means option D will be the correct answer. Question number 3 is from the chapter Mechanical Properties of Fluids, and the question is the amount of energy required to form a soap bubble of radius 2 cm from a soap solution is nearly. Surface tension of soap solution is 0.03 Newton per meter. Okay, so surface tension, that is T, is given as 0.03 Newton per meter and the radius of the soap bubble is given as 2 cm. It can be written as 2 into 10 to the power minus 2 meter, right? Now we have to find the amount of energy required to form this soap bubble. So that will be equal to surface tension into delta A, where A is the surface area, into 2. Okay, because in soap bubble we have two surfaces. Then here surface tension is equal to 0.03. Area will be 4 pi r square into 2. Okay, so let's put the values. 0.03 into 4 pi is equal to 3.14. R square, that means square of this radius, which will be equal to, r square will be equal to 4 into 10 to the power minus 4, right? So r square is 4 into 10 to the power minus 4 and then into 2. Okay, so on solving this we'll get 3.01 into 10 to the power minus 4, and the unit of energy will be joule. So this is the amount of energy required. So option B will be the correct answer. 3.01 into 10 to the power minus 4 joule. Question number 4 is from the chapter Semiconductor Electronics, and the question is resistance of a carbon resistor determined from color codes is 22,000 plus minus 5% ohm. The color of third band must be. Options are green, orange, yellow and red. Okay, so the resistance mentioned here is 22,000 plus minus 5%, which can be written as 22 into 10 to the power 3. Okay, plus minus 5%. Okay, now here this first digit, that is 2, will correspond to the first band. Next digit, that is this 2, will correspond to the second band, and the decimal multiplier, that is power of 10, will correspond to the third band about which the question has been asked. Okay, so we have to focus on number 3, right? Now we have to determine the color. So how to do that? We can remember a simple trick. You can remember a sentence that BB Roy of Great Britain had a very good wife. Okay, so this is corresponding to 1. Sorry, it is 0. Then next B will 1. R for red, that is 2. Then O 3, like that. Okay, so here we have to focus on number 3, which is related to letter O, and O for orange. Okay, orange. So the third band must be orange colored. So option B will be the correct answer. Now question number 5 is from the chapter Alternating Current, and the question is in a series LCR circuit, the inductance L is 10 millihenry, capacitance C is 1 microfarad and resistance R is 100 ohm. The frequency at which the resonance occurs is. Okay, so we know that for resonance the frequency should be 1 upon 2 pi under root LC, and according to this question L, that is inductance, is 10 millihenry, so it can be written as 10 into 10 to the power minus 3 henry. Capacitance is 1 microfarad, so it can be written as 1 into 10 to the power minus 6 farad. Okay, and the resistance R is 100 ohm. So we just have to put the value in this formula. Okay, so frequency will be equal to 1 by 2 pi, that means 2 into 3.14 under root LC. So L is 10 into 10 to the power minus 3. C is 1 into 10 to the power minus 6. Okay, there is no use of resistance here. So on solving this complete will be under root, right? On solving this, what do we get? We'll get 1.591 into 10 to the power 3. So it can be written as 1.591 kilohertz. Okay, because this was in hertz, so 10 to the power 3 can be written as kilo. So the correct option will be option number C, 1.59 kilohertz. Okay. Question number 6 is from electromagnetic radiation, and the question is in a plane electromagnetic wave traveling in free space, the electric field component oscillates sinusoidally at a frequency of 2 into 10 to the power 10 hertz and amplitude 48 volt per meter. Then the amplitude of oscillating magnetic field is. Okay, so here the amplitude of electric field, that is E naught, is given as 48 volt per meter, right? This is the amplitude of oscillating electric field, and we have to find out the amplitude of oscillating magnetic field, that is B naught. Okay, and the speed of light in free space, that is C, is given as 3 into 10 to the power 8 meter per second. The frequency has no use here because we know that from the properties of electromagnetic wave, C is equal to E naught upon B naught. Okay, E naught is the amplitude of electric field and B naught is the amplitude of magnetic field. Here we have to find the value of amplitude of magnetic field, that is B naught. So that will be equal to E naught upon C. Okay, E naught is 48 volt per meter and C is 3 into 10 to the power 8. 3 into 10 to the power 8. So here we get 1 and 6. 16 into 10 to the power minus 8, and the unit will be Tesla, right? So it can be written as 1.6 into 10 to the power minus 7 Tesla. So the correct option will be option number B, 1.6 into 10 to the power minus 7 Tesla. Question number 7 is from the chapter Semiconductor Electronics. Here two statements are given and we have to see which is correct. Okay. So the first statement says photovoltaic devices can convert optical radiation into electricity. So yes, this is a correct statement. We know that photovoltaic devices use photovoltaic effect to convert the light energy into electrical energy. Okay. So this is a correct statement. Then the second statement says Zener diode is designed to operate under reverse bias in breakdown region. This is also a correct statement. We know that Zener diode is used as a voltage regulator, right? Voltage regulator, and it is designed to operate under the reverse bias condition in breakdown region. So both are correct, right? So the first option says both statement 1 and statement 2 are incorrect. So this cannot be the correct answer. Then the second option says statement 1 is correct but statement 2 is incorrect. This is also not true because both are correct, right? Then the third one says statement 1 is incorrect and statement 2 is correct, not true. And the last one says both statement 1 and statement 2 are correct. Yes, this is the correct answer. Option D is the correct one. Question number 8 is from the chapter Units and Measurement, and the question is the errors in the measurement which arise due to unpredictable fluctuations in temperature and voltage supply are, options are personal errors, least count errors, random errors and instrumental errors. Okay, so we know that the errors which arise due to unpredictable fluctuations are known as random errors. Okay, so option C will be the correct answer. Let's write down the definition here. The errors which cannot be associated with any systematic or constant cause. Okay, any systematic or constant cause are known as random errors. So the cause is not systematic here. Okay, there is no systematic cause here. So this is very unpredictable and the fluctuations can be in pressure, temperature, voltage supply, anything. Okay, so these cannot be predicted, whereas all others are predictable types of errors. So option C is the correct answer. Question number 9 is from the chapter Electric Charges and Fields, and the question is integration of vector E dot vector ds equals to 0 over a surface, then option A, magnitude of electric field on the surface is constant, option B, all the charges must necessarily be inside the surface, option C, the electric field inside the surface is necessarily uniform, and the last option is the number of flux lines entering the surface must be equal to the number of flux lines leaving it. Okay, so here vector E dot vector ds equals to 0. What does this imply? It implies that the net flux through the surface is 0. Okay, net flux through surface is 0. Okay, and in what condition the net flux will be 0? When the number of flux line entering the surface will be equal to the number of flux lines leaving it. Okay, so it will make the net flux 0. So option D will be the correct answer. The number of flux lines entering the surface must be equal to the number of flux lines leaving the surface. Okay. Question number 10 is from the chapter Current Electricity, and the question is, if the galvanometer G does not show any deflection in the circuit shown, the value of R is given by. Okay, so it is given that this galvanometer does not show any deflection. It means no current will flow through this galvanometer. Okay, so when the current starts moving from this 10-volt battery, it will move through this 400 ohm resistance, and then it will move downwards towards this unknown resistance R, because it does not move further towards the galvanometer. Okay, then this resistance is unknown and we have to find out the value. Here the voltage drop will be same as this, that means 2 volt. Okay, so let's draw the simplified circuit here. Simplified circuit is like this. Here we have a 10-volt battery, then here we have a 400 ohm resistance, and then this side there is an unknown resistance R, where the voltage drop is 2 volt, and then the circuit is complete. The direction of current is like this. Okay, so now first we can find out the amount of current. Let's say this 10 volt is V1. Okay, V1 is 10 volt, and V2, that is this one, is 2 volt. Okay, and resistance is given as 400 ohm. So what will be the amount of current? We know that delta V will be equal to I into R. Okay, delta V is V1 minus V2, and that will be equal to I into R. Okay, so I will be equal to delta V that is V1 minus V2. So V1 is 10, V2 is 2 upon R, that means 400 ohm. Okay, so that will be equal to 8 by 400. So what do we get here? We'll get 2 into 10 to the power minus 2 ampere. Okay, so this is the amount of current that is flowing through this circuit. Now we have to find the value of R. Okay, that means we have to consider this arm only, this arm only. Okay, so the same current is flowing through this arm. So current is 2 into 10 to the power minus 2 ampere. Here the voltage will be 2 volt and R is unknown. Okay, so we'll use the same thing, that is V equals to IR. V is 2 volt, I is 2 into 10 to the power minus 2 ampere, and R is unknown. We simply have to find the value of R, right? So R will be equal to 2 divided by 2 into 10 to the power minus 2. So 2 is cancelled, 10 to the 1 by 10 to the power minus 2, that means 10 to the power 2 here. Okay, so that is equal to 100, and the unit of resistance will be ohm. So the answer is 100 ohm. That means option B will be the correct answer. Question number 11 is from the chapter Alternating Current, and the question is, an AC source is connected to a capacitor. Due to decrease in its operating frequency, option A, displacement current increases, option B, displacement current decreases, option C, capacitive reactance remains constant, and option D, capacitive reactance decreases. Okay, so we know that the capacitive reactance, that is Xc, is equal to 1 by omega C. Okay, where C is the capacitance and omega is the operating frequency. Okay, operating frequency. According to the question, there is decrease in its operating frequency. Okay, that means omega decreases. We know that Xc is inversely proportional to omega. So when omega will decrease, what will happen to Xc? It will increase. Okay, so when omega decreases, the capacitive reactance Xc increases. Okay, so capacitive reactance increases, right? So option D cannot be the correct answer, because it says that capacitive reactance decreases whereas it increases. It also does not remain constant, so option C is also incorrect. That means we have to relate it with the current. Now we know that reactance is the opposition to the current. Okay, reactance is the opposition to current. So when capacitive reactance increases, opposition to current will also increase. That means less current will be flowing. Okay, so the conduction current or displacement current will decrease. Okay, so when Xc increases, the conduction current or displacement current will decrease. Okay, so option B will be the correct answer. Displacement current decreases. Question number 12 is from the chapter Electromagnetic Waves, and the question is the minimum wavelength of X-rays produced by an electron accelerated through a potential difference of V volts is proportional to. Options are 1 by V, 1 by root V, V square and root V. Okay, so we know that the energy, that is EV, will be equal to Hc by lambda. Okay, so here minimum wavelength has to be considered, so lambda minimum. Okay, EV equals to Hc by lambda minimum. Now here we can write that lambda minimum will be equal to Hc by EV. Okay, and we have to find the relation between the wavelength lambda and potential difference V. So from here it is clear that lambda is inversely proportional to V. So it will be proportional to 1 by V. That means option A will be the correct answer. Question number 13 is from the chapter Mechanical Properties of Fluids, and the question is the Venturi meter works on. Options are Bernoulli's principle, the principle of parallel axis, the principle of perpendicular axis, and Huygens principle. Okay, so this is a direct question. We know that Venturi meter is an instrument that is used to measure the flow rate of fluid through a pipe, right? So it measures the flow rate of fluid through a pipe, and the principle that uses is Bernoulli's principle. So option A will be the correct answer. Question number 14 is from the chapter Semiconductor Electronics, and the question is a full wave rectifier circuit consists of two PN junction diodes, a center tapped transformer, capacitor and a load resistance. Which of these components remove the AC ripple from the rectified output? Option A, PN junction diodes, option B, capacitor, option C, load resistance, and option D, a center tapped transformer. Okay, so we know that capacitor is used to remove the AC ripple from the rectified output. Okay, capacitor. So what does it do? The smoothing capacitors, let's write it down here. Smoothing capacitors convert the ripple voltage into a DC voltage. Okay, into a smoother DC voltage. So this way they are used to remove the ripple, AC ripple, from the rectified output. So option B will be the correct answer. Question number 15 is from the chapter Units and Measurement, and the question is a metal wire has mass 0.4 plus minus 0.002 grams, radius 0.3 plus minus 0.001 millimeter, and length 5 plus minus 0.02 centimeter. The maximum possible percentage error in the measurement of density will nearly be. Okay, so here mass is 0.4 plus minus 0.002. That means m is 0.4 and delta m is 0.002. Okay, similarly radius r is 0.3 and delta r, that is change in radius, is 0.001, and length L is 5 whereas delta L is 0.02. Okay, now we know that the density rho is equal to mass by volume, and volume is equal to cross sectional area of the wire, that is pi r square, into length of the wire L. Okay, now using the concept of errors, we know that delta rho by rho, that is the error here in density, will be equal to delta m by m, that is error in mass, plus 2 times delta r by r, because we have r square in the formula, par is 2 here, so it will be multiplied by 2, plus delta L by L. Okay, so let's put the values here. Delta M is 0.002. So 0.002 upon M, that is 0.4, plus 2 into delta R. Delta R is 0.001 and R is 0.3, plus delta L is 0.02 and L is 5, right? Now we'll solve this, and on solving this we'll get 0.0156. This is the value of delta rho by rho. That means the error in density, but we have to find out the percentage error, right? So delta delta rho by rho percentage will be this value multiplied by 100. Okay, 0.0156 into 100, that will be equal to 1.56. Okay. Now in the option, we don't have 1.56%. So the approximate value will be 1.6. So option B will be the correct answer. Question number 16 is from the chapter Wave Optics, and the question is, for Young's double slit experiment, two statements are given below. First statement says if screen is moved away from the plane of slits, angular separation of the fringes remains constant. And second statement says if monochromatic source is replaced by another monochromatic source of larger wavelength, the angular separation of the fringes decreases. So in the light of the above statements, choose the correct answer from the options given below. Okay. So in double slit experiment, we know that there will be two slits. Okay. Let's say this is slit 1 and this is slit 2. And the distance between the two slits is taken as small d. Now, if there is a screen at this location, then the distance between the screen and the plane of the slits is taken as capital D, right? Now, what is the formula for angular fringe width or the angular separation of the fringes? That is taken as theta, okay? So, let's write it down here. Angular fringe width theta is equal to lambda upon small d. Okay, so this depends on the separation between the two slits, small d. Okay, and here the first statement says that if screen is moved away from the plane of slits, that means this screen is moved away. That means this capital D will increase, right? So in this case, angular separation of the fringes remains constant. Yes, this is a correct statement because we can see that this angular fringe width is independent of capital D. Okay, it does not depend on capital D, so it will remain constant. Now the second statement says if monochromatic source is replaced by another monochromatic source of larger wavelength. So in this case, wavelength increases, then the angular separation of the fringes decreases. So here from this formula we can see that the angular separation of the fringes or the angular fringe width is directly proportional to the wavelength, right? That means if wavelength will increase, then angular fringe width will also increase. But in the second statement, it is given that it will decrease. So this is not true. Okay. When the wavelength will increase, the angular fringe width will also increase. So the statement 1 is correct, but statement 2 is false. Okay. Statement 1 is true, but statement 2 is false. So option B will be the correct answer. Okay. Question number 17 is from the chapter Work, Energy and Power, and the question is the potential energy of a long spring when stretched by 2 cm is U. If the spring is stretched by 8 cm, the potential energy stored in it will be. Options are 4U, 8U, 16U and 2U. Okay. So we have to find the potential energy in the second case in terms of the initial potential energy, right? So what is the formula for potential energy stored in the spring? Let's write it down here. Potential energy stored in spring, that is U equals to half kx square. Okay, k is the spring constant and x is the displacement. Okay, that means how much this is stretched. Now in first case, U is equal to half k 2 square. Okay, because in first case the displacement is 2 centimeter. Okay, so x square will be 2 square. So let's solve it. It will be equal to half into k into 2 square, that is 4. So that will be equal to 2k, right? So the initial potential energy is 2k. Now in the second case, let's say this time the potential energy is U dash. Okay, so that will be equal to half into K into 8 square, because in the second case it is stretched by 8 centimeter. Okay, so that will be equal to half into K into square of 8 is 64. So here we'll get 32. So that is equal to 32K. Okay. So in the first case, the potential energy stored is 2K, and in the second case, it is 32K. Now, if we divide the first one by the second one, then U by U dash will be equal to 2K upon 32K. Okay, so K will be cancelled, and here we get 1 by 16, right? So what will be the new potential energy, that is U dash? U dash will be equal to 16 times the initial potential energy, that is 16U. Okay. So which option should be the correct one? Option number C will be the correct answer. Question number 18 is from the chapter Ray Optics and Optical Instruments, and the question is, light travels a distance x in time t1 in air and 10x in time t2 in another denser medium. Okay, what is the critical angle for this medium? So we know that the formula for critical angle is sin IC equals to 1 by mu, where IC is the critical angle, right? Critical angle. Also we know that mu is equal to C by V. So 1 by mu will be equal to V by C. What is V? V is the speed of light in any medium, and C is the speed of light in vacuum or air. Okay. So in first case, it is given that light travels a distance x in time t1 in air. Okay. So in air, the distance traveled by the light is given as x. Time is given as t1, right? And we know that the speed of light in air is c. So we can write that the speed c will be equal to distance upon time, that means x by t1, right? So this is the first case. And in the second case, that means in a denser medium, distance is given as, distance traveled by light is 10x, time is given as t2, right? And we know that the speed is taken as v in any medium. So from here, the speed v will be equal to distance by time, that means 10x by time t2. Okay, so this is equation number 2. Now from here, we have to find out the critical angle. So we know that sin IC equals to 1 by mu. We'll use this formula. Sin IC equals to 1 by mu, that is equal to V by C. Okay, so sin IC will be equal to V by C. V is equal to 10x by T2 and C is x by T1. So here we have to divide, so it will be T1 by x. Okay, so x cancelled. So this will be equal to 10 T1 by T2. This is sin IC. So what will be the value of IC, that is critical angle? It will be equal to sin inverse 10 T1 by T2, right? So this is the value. Okay, sin inverse 10 T1 by T2. So let's see the options. First option, we have sin inverse 10 T2 by T1, which is not true because it is 10 T1 by T2, right? In the second, we have sin inverse T1 by 10 T2. No, not correct. In the third one, we have sin inverse 10 T1 by T2. Yes, this is the correct answer. Option C will be the correct answer. Now question number 19 is from the chapter Alternating Current, and the question is, a 12 volt 60 watt lamp is connected to secondary of a step down transformer whose primary is connected to AC mains of 220 volt. Assuming the transformer to be ideal, what is the current in the primary winding? Okay, so we have, this is the primary winding of the transformer and this is the secondary winding. Okay, so it is given that a lamp is connected to the secondary winding. Okay, so here we have a lamp. This is the lamp. Okay, the voltage is 12 volt and the power is 60 watt, right? and the primary is connected to AC mains of 220 volt. Okay, so here we have the AC mains of 220 volt, right? Now we have to assume that the transformer is ideal. Okay, so for ideal transformer, for an ideal transformer, what is the condition? The input power will be equal to output power. Okay, so P input will be equal to P output. Input power will be equal to potential difference, the voltage into current. Okay, the mains voltage into the current, and the output power will be the power that is the power of the bulb. Okay, so that is equal to 60 watt. Now the mains voltage is 220 volt into current is equal to 60. So from here we can get the value of current in the primary winding, that is I equals to 60 divided by 220. Okay, so here we'll get 0.27 and the unit of current will be ampere. Okay, so 0.27 ampere, that means option D will be the correct answer. Question number 20 is related to vectors as well as laws of motion. And the question is, a football player is moving southwards and suddenly turns eastwards with the same speed to avoid an opponent. The force that acts on the player while turning is, options are along northward, along northeast, along southwest, and along eastwards. Okay, so we have to determine the direction of the force. So let's understand this. If we draw the axis here, this is north direction, this is south direction, this is east direction, this is west. Okay, now this is the x-axis, this is x-axis, right? So the unit vector along the positive side will be I cap, and on the negative side it will be minus I cap, right? Similarly on the y-axis, this is the y-axis, north south direction, here on the positive side the unit vector will be j cap, and on the negative side the unit vector will be minus j cap, right? Now here force can be determined by change in momentum. So what is the momentum here? The initial momentum will be equal to mass into velocity into the initial uh, vector. Unit vector will be what? Minus j cap. Okay, because the direction is southward direction, here the vector is minus j cap. Similarly, the final momentum will be equal to mass into velocity. Velocity is same, right? Speed is same, and direction is east direction, here the unit vector is I cap. So this side we have I cap. Now what will be the change in momentum? The change in momentum will be equal to final momentum minus initial momentum. Final momentum is mu I cap and initial momentum is mu minus j cap, right? If we take mu as common, what will be left inside the bracket? I cap minus minus will become plus, so I cap plus j cap. So this is the final direction of the momentum, right? And we know that the direction of the change in momentum will be the same as the direction of force acting on the player, right? So what is the direction? I cap plus j cap. That means this is I cap, this is j cap, right? So the resultant direction will be somewhere here. So this is east, this is north. So the resultant direction is northeast, right? So the correct answer will be option number B, along northeast. You got it? How the force will have the same direction? We know that force is equal to delta P by delta T. Okay, change in momentum per unit time. So the direction of force and change in momentum will be same, and here the direction of change in momentum is northeast, so the direction of force will also be along northeast only. So option B is the correct answer. Question number 21 is from the chapter Current Electricity, and the question is, the magnitude and direction of the current in the following circuit is. Okay, so here we can see that there is a potential 10 volt and then we have a potential of 5 volt this side. Okay, so how to find out the current? The current will be equal to delta V upon R, right? Delta V is the change in potential, so that will be equal to 10 volt minus 5 volt divided by the resistance. So what is the total resistance here? 2 ohm, 1 ohm and 7 ohm. So total resistance will be 2 plus 1 plus 7. Okay, 2 plus 1 plus 7 ohm. So 10 volt minus 5 volt means 5 volt, and this side we have 10 ohm. Okay, so that will be equal to 1 by 2, that is equal to 0.5 ampere. Okay, so the amount of current flowing is 0.5 ampere. And what will be the direction of the flow of current? We know that current always flows from higher potential to lower potential. Okay, direction is from higher potential towards the lower potential. Okay, that means it will flow from the 10 volt towards the 5 volts. Okay, 10 volts to 5 volts. So obviously it cannot be anti-clockwise, it will be clockwise only. So let's see the options. In the first option we have 0.5 ampere from A to B through E. Yes, this will be the correct, because A has higher potential than B. So this is correct. And the second option is incorrect, because 5 by 9 is not the amount of current. Third one is also incorrect, and the fourth one is also, only first option is the correct one. Question number 22 is related to rotational motion, and the question is the angular acceleration of a body moving along the circumference of a circle is option A along the radius towards the center, option B along the tangent to its position, option C along the axis of rotation, and option D along the radius away from the center. Okay, so this is a direct question. We know that when there is a motion along the circumference of a circle, then the angular acceleration is perpendicular to the plane of the rotation. Okay, that means along the axis of the rotation. Okay, so here the first option says that it is along the radius. No, it is not along the radius, it is perpendicular to the plane. Second option is along the tangent. This is also incorrect. Third one is along the axis. Yes, this is correct, because it is always perpendicular to the plane. And the last one is also incorrect. It is not along the radius. So option C is the correct answer. Question number 23 is from the chapter Motion in a Plane, specifically from projectile motion. And the question is, a bullet is fired from a gun at a speed of 280 meter per second in the direction 30° above the horizontal. The maximum height attained by the bullet is, okay, G is to be taken as 9.8 meter per second square, and sine 30° is given as 0.5. Okay, so the speed u is equal to 280 meter per second. The value of sine 30° is given as 0.5, and g, that is acceleration due to gravity, is equal to 9.8 meter per second square. Okay, so we know that the formula for height in case of projectile motion is u square sine square theta upon 2g. Okay, so this is directly formula based question. We just have to put the values. U is 280 meter per second square, so u square means square of 280, right? 280 square into sine square theta. Theta is 30° here, right? So sine square 30° divided by 2g. 2 into g is 9.8 meter per second square. So 280 square into sine 30 is equal to 0.5. So sine square 30 will be 0.25, right? And here we have 2 into 9.8. So on solving this, we'll get 1000, and the unit will be meter. Okay, so the correct answer will be option number B. 1000 meter will be the height, the maximum height attained by the bullet. Question number 24 is from EMI, and the question is the net magnetic flux through any closed surface is. Options are positive, infinity, negative, and 0. Okay, so we have any closed surface. What happens in case of closed surface? We know that the number of magnetic field lines entering the closed surface is equal to the number of field lines leaving the surface, right? Leaving the surface. So integration of vector B dot ds is 0. That means the net magnetic flux is 0. So option D will be the correct answer. Okay, this is the very simple question. Question number 25 is from capacitance, and the question is the equivalent capacitance of the system shown in the following circuit is. Okay, so suppose this is C1, this is C2 and this is C3. So we can see that C2 and C3 are in parallel combination. Okay, are parallel. So the equivalent capacitance will be equal to C2 plus C3, right? In case of parallel combination, the equivalent capacitance is the sum of capacitances, right? So C2 is 3 microfarad, C3 is 3 microfarad. Again, so the equivalent will be 6 microfarad. Okay. Now let's say this is C dash. So C dash is 6 microfarad. Now we can see that this equivalent is in series with C1. Okay. Now C1 and C dash are in series. So in series, what will be the equivalent capacitance? That will be equal to C1 C dash upon C1 plus C dash. Okay. So C1 is 3 microfarad, C dash is 6 microfarad, C1 is 3, C2 is C dash is 6. Okay. So 3 into 6 is 18 and 3 plus 6 is 9. So the equivalent. Question number 26 is from the chapter Motion in a Straight Line. And the question is, a vehicle travels half the distance with speed v and the remaining distance with speed 2v. Its average speed is. Okay. So we have a direct formula to find the average speed. We know that that is equal to 2v1 v2 upon v1 plus v2. Okay. So let's put the values here. Here v1 is equal to v and v2 is equal to 2v, right? So 2 into v1, that means v, into v2, that is 2v. Okay. Divided by v1 plus v2, that means v plus 2v. So here we get 2 into 2, 4, and v into v square. Okay. And here we get v plus 2v, that is 3v. So 1 square will cancel this v here. So what is left? 4 by 3 v. So the average speed will be 4 by 3v. That means option B will be the correct answer. Question number 27 is from the chapter Nuclei, and the question is, the half-life of a radioactive substance is 20 minutes. In how much time the activity of substance drops to 1/16th of its initial value? Okay. So if the initial activity is A naught, then activity after time t, that is A, is equal to 1/16 times 1 by 16 times A naught, right? According to this question. Now we know that A is equal to A naught by 2 to the power n. So from here we can say that A by A naught will be equal to 1 by 2 to the power n, right? And A is equal to 1 by 16 times A naught. Okay. So 1 by 16 times A naught, and here we have A naught on the denominator side as well, will be equal to 1 by 2 to the power n. Okay, A naught cancel. So 1 by 2 to the power n is equal to 1 by 16. That means 2 to the power n is equal to 16. So what will be the value of n? N will be 4, because 2 to the power 4 will be equal to 16, right? 2 to the power 4 will be equal to 16. So n equals to 4. And what is n? N is the number of half-lives. Okay, number of half-lives. So total how many half-lives are there? 4. Now we have to find out the time. Okay, so for that we have to use another formula, that n equals to total time t divided by the half-life. Okay, so this is the formula that we have to use. Capital T is the half-life and small t is the time taken. So we have to find out the time. So time will be equal to, time t will be equal to number of half-lives into half-life of the substance. Okay. So number of half-lives is 4 and half-life was given as 20 minutes. Okay. So capital T is 20 minutes. So 4 into 20 minutes, that is 80 minutes. Okay. So the total time will be 80 minutes. That means option number C will be the correct answer. Question number 28 is from the chapter Kinetic Theory of Gases, and the question is, the temperature of a gas is minus 50 degrees Celsius. To what temperature the gas should be heated so that the RMS speed is increased by 3 times. Okay. So here if the initial RMS speed, that is V1, is V, then it is given that it is increased by 3 times. Okay. So what will be the final RMS speed, that is V2? It will be initial speed plus the increase in the speed, that is 3V. V plus 3V, that means the final speed will be 4V. Okay. And the temperature, initial temperature is minus 50 degrees Celsius. So in Kelvin it will be 273 minus 50, that is 223 Kelvin. Okay, this is the initial temperature T1. Now we have to find out the value of T2. Okay. Now let's use the formula of RMS speed, that is equal to under root 3 RT by M. Okay, this is the formula for RMS speed. So here we can say that the RMS speed is directly proportional to root T, right? So V1 by V2 will be equal to under root T1 by T2. Okay, so let's just put the values. Initial the V1 is equal to V, V2 is equal to 4V, right? This time, this side we have T1 223. So 223 upon T2 is unknown. Okay. Now we have to remove the root. So on the left hand side we'll get a square. Okay. So first V will be cancelled and 1 by 4 will be left. So the square of this will be 1 by 16 and this side 223 upon T. And we have to find out the value of T. So that will be equal to 223 into 16. And on multiplying, what value do we get? We'll get 3568 Kelvin. Okay. So this is the final temperature, but here this value is not given in Kelvin. So we'll take out the value in Celsius. Okay. So in Celsius, 3568 Kelvin will be equal to 3568 minus 273 degrees Celsius, that is 3295 degrees Celsius. So is this value mentioned in the options? 3295 degrees Celsius? Yes, option A will be the correct answer. Question number 29 is from the chapter Thermodynamics, and the question is, a Carnot engine has an efficiency of 50% when its source is at a temperature 327 degrees Celsius. The temperature of the sink is, okay. So efficiency is given as 50%. That means 50 by 100. So it can be written as 1 by 2. Okay, so efficiency is 1 by 2. Now temperature of the source, that is T1, is given as 327 degrees Celsius. So in Kelvin it will be 327 plus 273 Kelvin. Okay. So it is 600 Kelvin. T1 is 600 Kelvin and we have to find out the temperature of the sink, that is T2. Okay. What is the formula for efficiency of Carnot engine? It is 1 minus T2 by T1, where T2 is the temperature of the sink and T1 is the temperature at the source. Okay. So let's put the values. Efficiency is given as half and this side we have 1 minus T2 by T1. So T2 is unknown, T1 is 600 Kelvin. Okay. So if we take T2 by 600 on the left hand side, what will be left on right hand side? It will be 1 minus half, that is half. Okay. So T2 will be equal to half into 600 Kelvin, that is equal to 300 Kelvin. But the options are given in degrees Celsius. So let's find in Celsius. So 300 Kelvin minus that will be equal to 300 minus 273 degrees Celsius. Okay. So that is equal to 27 degrees Celsius. So option number D will be the correct answer. Question number 30 is from the chapter Electromagnetic Induction, and the question is, the magnetic energy stored in an inductor of inductance 4 microhenry carrying a current of 2 ampere is. Okay, so the inductance, that is L, is equal to 4 microhenry, that means 4 into 10 to the power minus 6 Henry, right? And the current I is given as 2 ampere. So we have to find out the magnetic energy stored in the inductor. So formula for magnetic energy stored is half Li square. Okay, simply put the values. Half L is 4 into 10 to the power minus 6 and I is 2 ampere, so square of I will be square of 2. Okay, so on solving we'll get 8 into 10 to the power minus 6 and the unit of energy will be joule. So 8 into 10 to the power minus 6 joule, it can be written as 8 microjoule. Okay, so the correct option will be option number 6, 8 microjoule. Question number 31 is from the chapter Mechanical Properties of Solids, and the question is, let a wire be suspended from the ceiling, that is a rigid support, and stretched by a weight W attached at its free end. The longitudinal stress at any point of cross sectional area A of the wire is. Okay, so this is a ceiling here and a wire is suspended from the ceiling and it is stretched by a weight W. Okay, so there is a weight W here. Now we have to find out the longitudinal stress, and we know that the longitudinal stress is equal to internal restoring force divided by the area. Okay, so here the internal restoring force will be same as the weight that is suspended here, so that will be equal to W divided by the area, cross sectional area of the wire. So W by A, that means option A will be the correct answer. Okay, this is W by A. Question number 32 is from the chapter Electric Charges and Fields, and the question is, an electric dipole is placed at an angle of 30 degree with an electric field of intensity 2 into 10 to the power 5 Newton per coulomb. It experiences a torque equal to 4 Newton meter. Calculate the magnitude of charge on the dipole if the dipole length is 2 centimeter. Okay, so what is given here? Electric field intensity is given as 2 into 10 to the power 5 Newton per coulomb, right? Torque is given as 4 Newton meter. The angle theta is given as 30 degree and the dipole length, that is L, is given as 2 centimeter, which can be written as 0.02 meter, okay, in SI unit. And then we have to find out the magnitude of charge on the dipole, that is the value of Q is to be determined here. Okay, so first of all we know that torque vector tau is equal to vector P cross vector E, okay, where P is the dipole moment and E is the electric field intensity. So that will be equal to PE sine theta. PE sine theta. Let's put the values. Torque is given as 4 Newton meter. P is unknown, that we'll find out right now. Electric field intensity is 2 into 10 to the power 5 Newton per coulomb, and sine theta, that means sine 30 degree, which will be equal to half. Okay, so 4 equals to P into 2 into 10 to the power 5 into half. Sine 30 degrees half, so this 2 is cancelled. What is left here? P will be equal to 4 into 10 to the power minus 5, okay, meter. So this will be the value of dipole moment. This is the dipole moment. And we know that dipole moment is the product of individual charge, okay, and the length, the dipole length. If these are the charges, plus Q and minus Q, and this is the length of the dipole, then dipole moment is equal to Q into L, right? So from here we can get the value of Q because we already know what is the value of dipole moment, and the value of L is also given in this question. Okay, now we know that P is equal to Q into L, right? P is equal to 4 into 10 to the power minus 5. Q is unknown and L is equal to 0.02 meter. So from here we can say that Q will be equal to 4 into 10 to the power minus 5 divided by 0.02, that is 2 into 10 to the power minus 2. Okay, so it will be equal to 2 into 10 to the power minus 5 plus 2, that is 2 into 10 to the power 3. Okay, and the unit will be coulomb. So 2 into 10 to the power 3 coulomb, that can be written as 2 millicoulomb, right? Millicoulomb. So the correct option will be option number C, 2 millicoulomb. Okay. Now question number 33 is from the chapter atoms, and the question is, in hydrogen spectrum, the shortest wavelength in the Balmer series is lambda. The shortest wavelength in bracket series is, okay. So we have to find the shortest wavelength in the bracket series in terms of the wavelength of Balmer series. Okay, that means in terms of lambda. So for that we must remember the Rydberg's formula for hydrogen spectrum, that is 1 by lambda equals to R under bracket 1 by n2 square minus 1 by n1 square. Okay, so this formula must be kept in mind. Now we have two series here. First one is the Balmer series, and second series that we have to consider is bracket series, right? We know that for Balmer series n2 equals to 2 and n1 equals to infinity, whereas for bracket series n2 equals to 4 and n1 equals to infinity. Let's put these values in the Rydberg's formula. So for Balmer series it will be 1 by lambda equals to R under bracket 1 by 2 square minus 1 by infinity square. So 1 by lambda equals to R by 4, because 1 by infinity square will be 0. Okay. So from here we can say that the value of lambda is 4 by R, right? So we have got the value of lambda. Let's write it as equation number 1. Similarly for bracket series, 1 by lambda dash, let's assume that the wavelength in this case is lambda dash. So 1 by lambda dash is equal to R under bracket 1 by 4 square minus 1 by infinity square. So this time 1 by lambda dash will be equal to R by 16. So from here we can say that lambda dash is equal to 16 by R, right? Let's assume this is equation number 2. So we have to find out the value of lambda dash in terms of lambda. So on dividing equation 1 by equation 2, we'll get lambda by lambda dash equals to 4 by R into R by 16. Okay, so R cancelled. Here we'll get 1 by 4. So lambda by lambda dash is 1 by 4. So what will be the value of lambda dash? It will be 4 lambda. Okay, so the minimum wavelength in case of bracket is 4 times the wavelength of the Balmer series. Okay, shortest wavelength. Okay, so 4 lambda, that means option A will be the correct answer. Question number 34 is from the chapter Wave Optics, and the question is, the ratio of frequencies of fundamental harmonic produced by an open pipe to that of closed pipe having the same length is. Okay, so we have two pipes, one is open pipe and the other is closed pipe. Okay, so let's draw the open pipe first. Suppose this is the open pipe, so its fundamental harmonic will look something like this, and for closed pipe the fundamental harmonic will look like this. Okay, suppose this is point O, so we know that this is the node. Okay, in the closed pipe this is the node, point O are the nodes, and in open pipe we have two antinodes on either sides. Okay, so let's say this is point P, and closed pipe this is the antinode point P. Okay, what is the distance between a node and an antinode? That is equal to lambda by 4. Okay, we know that distance between a node and an antinode is equal to lambda by 4. Okay, so for open pipe the distance OP will be equal to lambda by 4, right? But this distance is half the total length of the pipe. Okay, in case of open, but this is half of L, if L is the total length of the pipe. Okay. So lambda by 4 is equal to L by 2. So from here we can say that lambda equals to 2L. Okay. So the wavelength in case of open pipe is equal to 2 times the length. Now for closed pipe. For closed pipe, we can see that the distance OP is equal to the total length of the pipe, right? So OP is equal to lambda by 4. So OP is equal to length. So L is equal to lambda by 4. So we can say that lambda, this is equal to 4L. Okay. Let's say this is lambda dash. Okay. The wavelength in case of closed is lambda dash. So we'll write it as equation number 2. Now we have to find the ratio of frequencies. So what is the formula for frequency? We know that frequency is equal to V upon lambda. Okay. V divided by lambda. So for open pipe, lambda is equal to 2L. Okay, this equation number 1. So what will be the value of frequency? Frequency in case of open pipe, that is FO, will be equal to V by 2L, right? Similarly, for closed pipe, lambda is equal to 4L. Okay, lambda dash is equal to 4L. So the frequency in case of closed pipe, FC, will be equal to V by 4L. Okay, now we have to find the ratio of these two. Okay, so the ratio of frequency in case of open to that of closed will be equal to V by 2L into 4L by V. So V is cancelled. What is left here? L is also cancelled. So it will be equal to 2:1. Okay, so the ratio will be equal to 2:1. So let's see the options. In the first option only we have this 2:1 ratio. So option A will be the correct answer. Question number 35 is from the chapter Gravitation, and the question is, two bodies of mass m and 9m are placed at a distance r. The gravitational potential on the line joining the bodies where the gravitational field equals 0 will be. Okay, G is the gravitational constant. So we have two bodies here. First body has mass m and the other has mass 9m. The distance between these two bodies is given as capital R. Also, it is given that there is a point in this line where the gravitational field is equal to 0. So let's assume that this is the point Q where the gravitational field is 0. Okay. Now let the distance between mass m and this point Q be x. So what will be the distance between Q and 9m? It will be r minus x. Okay. Now, why this gravitational field should be 0? So for that, the gravitational field due to this mass m must be equal to the gravitational field due to mass 9m. Okay, so both will cancel out each other and the net field will be 0. Okay, so for gravitational field at Q to be 0, the gravitational field due to mass m must be equal to the gravitational field due to mass 9m. Okay, so that they can cancel out each other. What is the formula for gravitational field? It is gm by x square. Okay, so g into m, that is small m, by the distance square. So the distance is x here with point Q, so it is x square, and this side again g, that is gravitational constant, then mass is 9m this time, and the distance is r minus x. Okay, so r minus x square. So these two are equal. Now let's solve them. M is on both sides, G is on both sides, so these will be cancelled. What is left here? 1 by x square equals to 9 by r minus x square. Okay, so from here we can write r minus x square by x square equals to 9. So if we find the roots on both sides, it will be r minus x by x equals to 3, right? We have found the root. So from here we can say that r is equal to 3x plus x, that is 4x. So what will be the value of x? The distance x will be equal to r by 4. Okay, this is the distance of mass m, or the body with mass m with point Q. Okay, So what will be the distance of mass 9m with point Q? It will be r minus x. Okay. So r minus x will be equal to r minus r by 4, that is 3r by 4. Okay. So the distance of mass m is r by 4 and the distance of mass 9m is 3r by 4 with the point Q. Okay. Now we have to find out the potential at point Q. Okay. Potential at point Q will be equal to potential due to mass m plus the gravitational potential. We are talking about the gravitational potential, right? Gravitational potential due to mass 9m. Okay. Now we know that the formula for gravitational potential is minus gm by x. Okay. X is the distance. So due to mass m, it will be minus gm by x, and due to mass 9m, it will be minus g into 9m upon r minus x. Okay. Now we'll put the values of x and r minus x as we have calculated as 0.1 and 2. Okay. So let's put these values. Minus gm by x is equal to r by 4, right? R by 4, and this side we have minus g into 9m by r minus x is 3r by 4. So 3r by 4. We'll further solve it to get the final potential. Okay. So here it will be minus 4 gm by r, and this side it will be 12 gm by r. Okay. You got it how? Let's see. Here we have minus g into 9m by 3r by 4. So 4 will move up. Okay. 4 will move up, and here we'll have 3r. So it will be 9 into 4 will be 36. So 36 by 3 will be 12. Okay. So minus 12 gm by r. So on solving this, we'll get minus 16 gm by r. So this is the gravitational potential at point Q. So let's see the options. In option number B, we have minus 16 gm by r. So option B will be the correct answer. Now we are starting section B of physics paper, and the first question of this section is from the chapter Motion in a Straight Line. And it says a bullet from a gun is fired on a rectangular wooden block with velocity u. When bullet travels 24 cm through the block along its length horizontally, velocity of bullet becomes u by 3. Then it further penetrates into the block in the same direction before coming to rest exactly at the other end of the block. The total length of the block is, okay. So we have a rectangular wooden block. Suppose this is the block. Here a bullet is fired on one end of the block. Okay. Suppose this is point A where the bullet has been fired. Here the velocity of the bullet is u. Then it travels a distance of 24 centimeter, and then it becomes u by 3. Okay, velocity becomes u by 3. So let's say this is point B where the velocity becomes u by 3. Then it further penetrates into the block, and just at the other end of the block, that is at point C, the velocity becomes 0 because it comes to rest here. Okay. Now we have three different points A, B and C where the velocities of the bullet are u, u by 3 and 0 respectively. Okay. So we can divide the motion of the bullet in two parts. First from point A to point B, and then from point B to C. Okay. So let's say from point A to B, what will be the initial velocity? Initial velocity will be the velocity at point A, that is u. Okay. And final velocity will be the velocity at point B, that is u by 3. What is the distance traveled? That is s is equals to 24 centimeter. Okay. So we can find out the acceleration by using the equation v square equals to u square minus 2as. Okay. So generally we write v square equals to u square plus 2as, but here since the velocity of the bullet is decreasing due to opposition from the block, so we can say that there is retardation. And in case of retardation, we put a minus sign. Okay. So let's put the values here. V is u by 3. So u square by 9. Okay, v square will be u square by 9. This side we have u square minus 2a into s is 24 centimeter. So 2a into 24 is 48, right? So we'll bring this to the left hand side. So 48a will be equal to u square minus u square by 9. Okay, that is u square by 8 u square by 9. Okay, so 48a equals to 8 u square by 9. That means the value of acceleration will be u square by 54. Okay, so this is the value of acceleration of the bullet. Now we'll use this in the next part, that is from B to C. Okay, so from point B to C now, the initial velocity will be the velocity at point B, that is u by 3. Okay, and the final velocity will be the velocity at point C, that is 0. This time we know the value of acceleration, that is u square by 54, but we don't know the distance traveled by the bullet from point B to C. So let's find out. Again we'll use the same equation, v square equals to u square minus 2as. This time v is 0, so v square will be 0. U is u by 3, so u square will be u square by 9. And this side we have minus 2, a is u square by 54, and s is unknown. Okay, so 2 into 27 will be 54. U square by 9 will be equal to u square s by 27. Okay, so u square cancelled. Can we find out the value of s here? 9 into 3 is 27. So s will be equal to 3 centimeter, right? So the distance traveled from point B to C will be 3 centimeter. Okay, from A to B it is 24 centimeter. Look at this block, diagram of the block, and from B to C we have seen that it is 3 centimeter. Okay, so the total length of the block will be what? Total length will be AB plus BC, that is 24 plus 3 centimeter. So that will be equal to 27 centimeter. Okay, this is the total length of the block. So option D will be the correct answer. Question number 37 is from the chapter Atoms, and the question is, the radius of innermost orbit of hydrogen atom is 5.3 into 10 to the power minus 11 meter. What is the radius of third allowed orbit of hydrogen atom? Okay, so innermost orbit means n1 equals to 1, and the radius in this orbit, that is r1, is given as 5.3 into 10 to the power minus 11 meter. Okay, we have to find the radius in third allowed orbit. So n2 is equal to 3, and we have to find out the value of r2. Okay, now we know that the radius in nth orbit is equal to n square by z, where z is the atomic number, and for hydrogen z is equal to 1. So we can say that r is proportional to n square. Okay, it means r1 by r2 will be equal to n1 by n2 square. Okay, so r1 by r2 will be equal to, n1 is 1, n2 is 3. 1 by 3 square, that is equal to 1 by 9. Okay, so we have to find out the value of r2, that will be equal to 9 into r1. That means 9 into, the value of r1 is 5.3 into 10 to the power minus 11 meter. Okay, so on solving this, we'll get 47.7 into 10 to the power minus 11 meter. Okay, but in the options we have angstrom unit. Okay, so it can be written as 4.77 into 10 to the power minus 10 meter, and minus 10 meter means angstrom, so it will be equal to 4.77 angstrom. Okay, so the correct option will be option number C, 4.77 angstrom. Now question number 38 is from the chapter Friction, and the question is, calculate the maximum acceleration of a moving car so that a body lying on the floor of the car remains stationary. The coefficient of static friction between the body and the floor is 0.15. Okay, so we have a moving car. On the floor of this car we have a body of mass m. What will be the forces acting on this body? There will be a downward force that will be equal to mg. Then there will be an upward normal force that will be balancing this downward force. Okay, so N will be equal to downward force mg. Okay, Let's say this is equation number 1. Now, there will be a pseudo force on this body in one direction that will be equal to ma, mass into acceleration, that will tend to move the body in this direction, okay, in the direction opposite to the motion of the car, okay. If the car is moving in right direction, then this pseudo force will be in the left direction. But in the direction opposite to this, there will be a frictional force that will tend to oppose this motion, okay. Now, for the body to remain stationary, what is the condition? This frictional force and this ma, that is the pseudo force, must be balanced, okay, so that the body does not move in either direction, okay. So for body to remain stationary, body to remain stationary, the frictional force must balance the pseudo force, okay, must balance the pseudo force. That is, frictional force Fr will be equal to ma, okay. Let's say this is equation number 2. Now we'll use the formula. We know that the frictional force is less than or equal to mu into n, where mu is the coefficient of static friction, so mu s, and n is the normal, okay. So if we write it as Fr equals to mu s into n, then from equation 1 we can write that n is equal to mg, so it will be mu s into mg. And from equation 2 we know that frictional force is equal to ma, okay, ma, right. So now m is on both sides, so we can find out the value of a is equal to mu s into g, okay. A is equal to mu s, that is coefficient of static friction, into the acceleration due to gravity g. If we put the value, mu s is equal to 0.15 and g is equal to 10, so on solving this we'll get 1.5, and the unit for acceleration will be meter per second square. So the correct answer will be option number B, 1.5 meter per second square. Okay. Now question number 39 is from the chapter current electricity, and the question is 10 resistors, each of resistance R, are connected in series to a battery of EMF E and negligible internal resistance. Then those are connected in parallel to the same battery. The current is increased n times. The value of n is, okay. So we have two situations here. In first situation, there is a series combination of resistances, okay. Series combination of how many resistances? 10 resistors, okay. So the equivalent resistance will be equal to 10R because 10 resistors are connected in series. Then the EMF of the battery is given as E. So what will be the value of current? Current will be equal to EMF by R equivalent, right? That is E by 10R, okay. So this is the value of current in the first case. Now, in the second case, the same resistors are connected in parallel, okay. So there is a parallel combination of resistances, and this time the equivalent resistance will be equal to R by 10, okay, in case of parallel. And the battery is same, so the EMF will be E only, okay. And what will be the current in this case? Current will be again EMF by equivalent resistance, that is E by, this time equivalent resistance is R by 10. So R and 10 will go up. So 10 E by R, okay. So this time the current is 10 E by R. Let's say the current in the first case was I and the current in the second case is I dash, okay. So according to the question, I dash is n times the I, okay, 10 times the initial current, okay. So according to question, I dash is n times the initial current I, okay. I dash is 10 E by R, and that is n times E by 10R, okay, E by 10R. So what will be the value of n, okay. So let's see, R is on both sides, so it will be cancelled. E is on both sides, so cancel. So N will be equal to 10 into 10, that is 100. Okay, so the value of N is 100. Now let's see the options. First option will be the correct answer. Okay. Question number 40 is from the chapter Motion in a Straight Line, and the question is, a horizontal bridge is built across a river. A student standing on the bridge throws a small ball vertically upwards with a velocity 4 meter per second. The ball strikes the water surface after 4 seconds. The height of the bridge above water surface is, take G equals to 10 meter per second square. Okay, so we have a horizontal bridge that is built across a river. Okay, a student is standing here. He throws a small ball vertically upwards with a speed of 4 meter per second. Okay, velocity of 4 meter per second. So this is the initial velocity of the ball. Okay, and then the ball strikes the surface of water somewhere here after 4 seconds. Okay, so t is equal to 4 seconds, and we have to find out the height of the bridge above the water surface. Okay, this is h. Okay, now let's put the formula S equals to ut minus half gt square. So in this case S is nothing but the height. Okay, so h equals to ut minus half gt square. U is equal to 4 meter per second. T is equal to 4 seconds minus half G is 10 meter per second square, and time is 4 seconds, so the square of time will be 16 seconds. Okay, so 2 into 8 is 16, 4 into 4 is 16 minus 80. Okay, and the unit of height will be meter, so 16 minus 80 means minus 64 meter. So this height is 64 meter, but minus sign shows that we are measuring from the top. Question number 41 is from the chapter Alternating Current, and the question is, the net impedance of circuit as shown in figure will be. Okay, so we can see that the inductance is given as 50 by pi millihenry, capacitance is 10 to the power 3 by pi microfarad, and resistance is 10 ohm. Okay, frequency is 50 hertz. Now inductance L is given as 50 by pi millihenry, that is into 10 to the power minus 3 Henry. And we know that the inductive reactance, that is XL, is equal to omega into L. What is omega? It is the angular velocity, and we know that omega is equal to 2 pi into frequency F. Frequency is given as 50 hertz here. So in place of omega we can write 2 pi into 50, and L is 50 by pi into 10 to the power minus 3 Henry. Okay, so on solving this we'll get 5 ohm. Okay, unit will be ohm, so 5 ohm. Now capacitance C is given as 10 to the power 3 by pi microfarad, that is into 10 to the power minus 6 farad. Okay, so capacitive reactance, that is Xc, is equal to 1 by omega c. This is the formula for capacitive reactance. Again, in place of omega we'll write 1 by in place of omega we'll write 2 pi f. Okay, so 1 by 2 pi, frequency is 50 and c is 10 to the power 3, pi will go up, and 10 to the power minus 6 will be written as 10 to the power 6 on the numerator side. Okay, so on solving this we'll get 10 ohm. So now we have got the value of XL, that is 5 ohm, and XC is 10 ohm. Okay, XL is 5 ohm, XC is 10 ohm, and the resistance R is given as 10 ohm. Okay, so these are the values using which we can find out the final impedance. Okay, so the net impedance, that is Z, is equal to under root, what is the formula? XC minus XL whole square plus R square. Okay, so simply we have to put the values and we'll get the answer. So XC under root, XC means 10, XL is 5 plus 10 square. Okay, so under root 10 minus 5 means 5 square will be 25, and this side we have 100. So this is under root 125, that will be equal to 5 root 5, and the unit will be ohm. So the correct answer will be option number B, 5 root 5 ohm is the net impedance. Okay. Question number 42 is from the chapter Gravitation, and the question is, A satellite is orbiting just above the surface of the Earth with time period t. If d is the density of the Earth and g is the universal constant of gravitation, the quantity 3 pi by gd represents. Okay. So what is time period of a satellite? We know that time period of a satellite is equal to 2 pi under root r cube upon g into m. So r is the radius of the earth and m is mass of the earth here. Okay. But here density is mentioned in the question. That means we'll have to write mass in terms of density. So mass is equal to volume into density, isn't it? What is the volume of earth? It is 4 by 3 pi r cube, and density is here. So we can put 4 by 3 pi r cube into density in place of mass in this equation. Okay. So time period will be equal to 2 pi under root r cube upon g into m, and in place of m we are writing 4 by 3 pi r cube d. So 4 by 3, so 3 will go up, pi r cube into d. Now r cube will be cancelled. So what is left? Time period is equal to 2 pi under root 3 by 4g pi d. Okay. Now we have to remove root from here. So let's square on both sides. Okay. So on squaring both sides, we get, on the left hand side we'll get t square, and on the right hand side square of 2 pi will be 4 pi square, and the square of this root part, just root will be removed. Okay. So 3 by 4 g pi d. So 4 cancelled, 1 pi will be cancelled here. So it will be equal to 3 pi by gd. Same thing that is mentioned in this question. Okay. We had to find the value of 3 pi by gd. So here we can see that this is equal to t square. Okay. So the correct answer will be option number A. The quantity 3 pi by gd represents t square. So option A is the correct answer. Question number 43 is from the chapter Ray Optics and Optical Instruments, and the question is, two thin lenses are of same focal length f, but one is convex and the other is concave. When they are placed in contact with each other, the equivalent focal length of the combination will be. Okay. So let's say the focal length of the convex lens is f1, and we know that the focal length of a convex lens is always positive. Okay. So this is greater than 0. That means positive, right? And if we assume that the focal length of the concave lens is f2, then f2 will be negative, that is less than 0. Okay, because focal length of a concave lens is always negative. Now we have to find out the equivalent focal length of the combination. So we know that 1 by equivalent focal length will be equal to 1 by f1 plus 1 by f2, but here f2 is in negative, so it will be minus 1 by f2. Okay. So both the quantity are same. So 1 by f minus 1 by f, that is 0. So 1 by f equivalent is 0. So f equivalent will be equal to 1 by 0, that is undefined. Okay. Or we can say infinity. Okay. It is equal to infinity. So infinite will be the correct answer. Option C will be the correct answer. Question number 44 is from the chapter Semiconductor Electronics, and the question is, for the following logic circuit, the truth table is. Okay. So A and B are the inputs here. Both are passing individually from the NOT gates. Okay. NOT gates. So after passing through the NOT gate, A will become A bar and B will also become B bar. Okay. Now these are the inputs for this NAND gate. Okay. This is NAND gate. So the inputs are A bar and B bar. We know that in case of simple AND gate, we put a dot between the inputs. Okay. So inputs are A bar and B bar. So in case of AND gate, we'll put a dot. That means A bar dot B bar. But since this is NAND gate, that means AND plus NOT. So there will be a bar on this. So the final output will be A bar dot B bar and a bar on that. Okay. So the output is A bar dot B bar and a bar on this. This is the output. And we know that A bar dot B bar is equal to A plus B bar, right? So if we put this, a plus b bar. There was an additional bar here. Okay, so it is a plus b double bar, which will become a plus b. Okay, so the final output will be a plus b. That is an OR gate. Okay, that is an output of OR gate. So what is the logic circuit in case of OR gate? We know that in case of OR gates, at least one of the inputs should be 1. Okay, so at least one input should be 1, then the output will be 1. Okay, then the output will be 1. This is the case for OR gate, but in case of AND gate, both the inputs should be 1. Okay, so if we have input 0 0, in that case output will also be 0, because at least one input should be 1. If we write 1 0, then yes, output will be 1, because at least one is 1. Okay, then 0 1, again output will be 1. And if both are 1, then definitely the output will be 1. Okay, so this will be the logic circuit of OR gate. So let's see. First one, yes, first one only is the correct one. So option A is the correct answer here. Now question number 45 is from the chapter Moving Charges and Magnetism. And the question is, a very long conducting wire is bent in a semicircular shape from A to B as shown in figure. The magnetic field at point P for steady current configuration is given by. Okay, so we can divide the wire into three parts here. First part is the upper straight part. Second part is the lower straight part, and the third one is the curved part or the semicircular part. Okay, so for the first part, the direction of the current is like this. What will be the magnitude of magnetic field? That is B1 will be equal to mu naught I by 4 pi r, right, due to the straight wire. For the second part, the direction of current is like this, and the magnitude of the magnetic field, that is B2, will be equal to again mu naught I by 4 pi r, because this is also due to the straight part. Okay, whereas for the third part, that is the semicircular part, the magnitude of the magnetic field, that is B3, will be equal to mu naught I by 4r. Now what will be the direction of the magnetic field? So in the first case, we can see that this is the direction of the current. So the direction of magnetic field will be around this wire, and whether inwards or outwards. So for that you can remember a simple trick. Suppose you are moving in the direction of the current, then which one is your right side? This is your right side, this is your left side, right? If the point lies on your right hand side, then the direction of the magnetic field will be inwards. Okay, so there will be a cross sign in this case. Whereas if the point lies on your left hand side, then the direction of magnetic field will be outwards, and there will be a dot sign. So here, if you see point P lies on the right side of this wire, so there will be a cross sign. Okay, cross sign. And in the second case also it is on the right side, so again there will be a cross sign. Whereas in case of semicircular part, suppose you are moving in the direction of the arrow, then the point P lies on your left hand side, right, left hand side, so there will be a dot sign. That means the direction will be outwards or away from the people. Okay, now the net magnetic field at point P due to all these parts will be the sum of B1, B2 and B3. Okay, so first let's find the sum of B1 and B2. B1 plus B2 will be equal to mu naught I by 2 pi r. Okay, and the direction will be cross because both are cross, so the resultant will also have the same direction. Okay, let's say this is B dash. Then we'll add B dash and B3. Okay, but we can see that B dash has a cross and B3 has a dot. That means they have opposite directions. Okay, so B3 plus B dash can be written as B3 minus B dash, because they have opposite direction. Okay, due to opposite direction, one will be in minus sign. So what is B3? It is mu naught I by 4r. And what is B dash? It is mu naught I by 2 pi r. Okay, now if we take mu naught I by 4 common, because in all the given options mu naught I by 4r are taken common. So let's take mu naught I by 4r outside the bracket. So what will be left? First 1 on this side, and this side we have 2 by pi. Okay. So mu naught I by 4r, 1 minus 2 by pi. That means whether B or C. Okay. It can either be B or C. Now what is the direction? So inside the bracket we have 1 and 2 by pi. 1 is part of this one, semicircular part, whereas 2 by pi is part of the straight parts. Okay. So the first one will be dominant in direction. Okay. We'll have the dominant direction. So one is part of the semicircular part, right? So semicircular is outwards. The direction of the semicircular part is outwards. So the final direction will also be outwards or away from the paper. So option B will be the correct answer. Suppose we write B dash minus B3. So what will happen? See, here we have taken B3 minus B dash. If we write B dash minus B3, then things will reverse. Okay, it will become mu naught I by 2 pi r minus mu naught I by 4r. Okay, again if we take mu naught I by 4r common, so this time on the left side we'll have 2 by pi, and on the right side we will have 1. Okay, so this time 1 is part of semicircular part and it is on the minus sign, so that how the direction can be dominant. So see, this is not given in your options. 2 by pi minus 1 is not given in any options, so we'll have to reverse it. We'll take minus sign outside and then we'll convert it into minus mu naught I by 4r, then 1 minus 2 by pi. Okay, so again 1 will become dominant. Okay, and 1 is part of the semicircular equation, so its direction will be dominant, that is a dot 1, and minus sign just represents that the direction has been changed. Okay, so the correct answer will be option number B. Now question number 46 is from the chapter current electricity, and the question is the resistance of platinum wire at 0 degrees Celsius is 2 ohm and 6.8 ohm at 80 degrees Celsius. The temperature coefficient of resistance of the wire is, okay. So the resistance at 0 degrees Celsius, that is R0, is 2 ohm, and the resistance at 80 degrees Celsius, that is R, is 6.8 ohm, right? Then we have T1 0 degrees Celsius and T2 80 degrees Celsius. So what will be the delta T? That means change in temperature. It will be 80 minus 0, that is 80. Okay. We have to find out the value of temperature coefficient of resistance, that is alpha, right? So we'll use the formula R equals to R0 1 plus alpha delta T. Okay. So this is simple formula based question. R is 6.8 ohm. R0 is 2 ohm. 1 plus alpha into delta T is 80. So it will be 80 alpha, right? Now if we bring 2 this side, it will divide 6.8. So it will become 3.4. So we can write that 1 plus 80 alpha equals to 3.4. Now again if we bring 1 on this side, it will be 3.4 minus 1, that is 2.4. So 80 alpha equals to 2.4. So alpha will be equal to 2.4 divided by 80, that is 24 divided by 800. Okay, so it will be 3 by 100. It can be written as 3 into 10 to the power minus 2, and the unit will be per degree centigrade. Okay, per degree Celsius. So it will be C minus 1. Okay, so the correct option will be 3. The first one says 10 to the power minus C. This is not correct. Second one will be the correct answer. Okay, 3 into 10 to the power minus 2 per degree Celsius. Okay, option B is the correct answer. Question number 47 is from the chapter electrostatic potential and capacitance, and the question is an electric dipole is placed as shown in the figure. Okay, so this is the dipole minus q charge and plus q charge. The length of the dipole is 3 centimeter plus 3 centimeter, that is 6 centimeter. Okay, then we have a point P which lies on the same line as that of the dipole, and the distance between this point P and the dipole is 5 centimeter, which is very less, even lesser than the length of the dipole. So we'll not consider it as a dipole here. We'll consider two individual charges because this point P is very close to it. Okay, so we'll consider two point charges plus Q and minus Q here. Okay, now here you can see that from point O to point P, the distance is 5 centimeter, and from point O to this plus Q charge, the distance is 3 centimeter. That means this distance between plus Q charge and P will be 5 centimeter minus 3 centimeter, that is 2 centimeter. Okay, so distance between plus Q and point P is 2 centimeter, right? That is 2 into 10 to the power minus 2 meter. Whereas the distance between minus Q charge and P is 6 centimeter, from minus Q to plus Q and then plus 2 centimeter, that is 8 centimeter. Okay, so it can be written as 8 into 10 to the power minus 2 meter. Okay, so we have to keep these in mind. Then we know that the electrostatic potential due to a point charge is given by kq by r, where r is the distance between the point charge and the point where we are finding the potential. Okay, so the electrostatic potential due to plus q charge will be kq by r, that is the distance is 2 into 10 to the power minus 2 meter, right? 2 into 10 to the power minus 2 meter. So this is the first one. And the electrostatic potential due to minus q charge will be minus kq by the distance in this case is 8 centimeter, that is 8 into 10 to the power minus 2 meter. So this is the second one. So the total potential will be the sum of these two. Okay, so the net potential at point P will be 1 plus 2, that is kq by 2 into 10 to the power minus 2 plus, but here we have a minus sign, so we'll put a minus kq by 8 into 10 to the power minus 2. Okay, so let's see, kq by 2 into 10 to the power minus 2 will be common. Here 1, and this side we have 1 by 4. Okay, so this 10 to the power minus 2 will go up and it will become 10 to the power 2. Okay, so kq into 10 to the power 2 divided by 2, and this side we have 4 minus 1, that is 3 by 4. Okay, so this 2 into 4 will become 8. So the answer will be 3 by 8 kq into 10 to the power 2. So 10 to the power 2 is already mentioned in the question, that the answer will be in 10 to the power 2. So the main thing is 3 by 8 kq. Okay, so 3 by 8 kq, that means option D will be the correct answer. Question number 48 is from the chapter Ray Optics and Optical Instruments, and the question is, in the figure shown here, what is the equivalent focal length of the combination of lenses? Assume that all layers are thin. Okay, so here you can see there is a combination of lenses. Two lenses are represented as shaded parts here, okay, on the left side and right side, and in between them there is an unshaded convex lens. Okay, so let's separate them. On the left side we have this lens, it looks like this. Okay, it is shown as shaded part. Let's say this is lens number 1. Then in between we have a convex lens, this is lens number 2, and on the right side we have a lens similar to the first one, it looks like this. This is lens number 3. Okay, now the radii of the convex lens R1 and R2 are same, and that is equal to 20 centimeter. So this is 20 centimeter, and this side also radius is 20 centimeter. For the first one, this is a straight line, so the radius will be infinity. Okay, and on the right side it will be same as that of the convex lens, that is 20 centimeter. Similarly for the third one, this is infinity and this is 20 centimeter. Okay, now we know the formula, 1 by f equals to mu minus 1 1 by R1 minus 1 by R2. Okay. So we'll use this formula to find the equivalent focal length. Okay. Now for the first lens, 1 by f1 will be equal to mu minus 1. What is the refractive index of the first lens? This shaded lens is 1.6. Okay. So 1.6 minus 1, and this side we have 1 by R1 minus 1 by R2. So R1 is infinity minus 1 by 20. Okay, R2 is 20. Now if you solve this, you will get minus 3 by 100. Now for second lens. So for second lens, that is a convex lens, 1 by f2 will be equal to, what is the refractive index of the second lens? It is 1.5. Okay, so 1.5 minus 1 by 20 minus 1 by 20, because for the convex lens both the radii are same, that is 20 centimeter. Okay, but here one radii will have opposite sign, so it will become 1 by 20 plus 1 by 20. Okay, so on solving this we'll get 1 by 20. Okay, so 1 by f1 is minus 3 by 100 and 1 by f2 is 1 by 20. Similarly, 1 by the third one, for the third lens, 1 by f3 will be same as that of the first one, that is minus 3 by 100. Okay, now we have to find out the equivalent focal length. So 1 by f equivalent is equal to 1 by f1 plus 1 by f2 plus 1 by f3, that is minus 3 by 100 plus 1 by 20 minus 3 by 100 again. So this is equal to minus 1 by 100. Okay, this is 1 by f equivalent, but we have to find the f equivalent, that means reverse of this. So minus 100. Okay, or minus 10 to the power 2. So let's see, minus 100 centimeter. Yes, this will be the correct answer, option B. Now question number 49 is related to magnetism as well as vectors, and the question is, a wire carrying a current I along the positive x-axis has length L. It is kept in a magnetic field vector B equals to 2I cap plus 3J cap minus 4K cap Tesla. The magnitude of the magnetic force acting on the wire is. Okay, so a wire of length L is lying along the x-axis, so its unit vector will be I cap. Okay, so it can be written as L I cap, right? Now what is the formula for magnetic force? Force is equal to I, current I, vector L cross vector B, where L is the length of the wire and B is the magnetic field. Okay, so I, vector L can be written as L I cap because it is along the x-axis, cross vector B, that is 2I cap plus 3J cap minus 4K cap, right? Now here you should remember that when we are finding the cross products, then what will be the resultant unit vector? So this is I cap, this is J cap, this is K cap. Okay, so if we are finding I cap cross J cap, the resultant vector will be K cap. Similarly, J cap cross K cap will get I cap, and K cap cross I cap will be J cap. If the direction is opposite, that is anti-clockwise, the same answer will be in minus. Okay, that means if we are finding J cap cross I cap, then it will be minus K cap. Okay, similarly it will be minus for all. Okay, in case of anti-clockwise direction. So let's see, now first part, that is L I cap cross 2 I cap. So I cap cross I cap will be 0. If the unit vectors are same, then the cross product will be 0. Okay, so the second one, that is L I cap cross 3 J cap. It will be 3 L, and I cap cross J cap will be K cap, right? Minus 4 L, I cap cross K cap will be minus J cap. So minus minus will become plus, it will be J cap. Okay, so let's open the bracket, 3IL K cap plus 4IL J cap. Okay, this is the vector form of the magnetic force. Okay, this is the vector form. And what will be the magnitude? The magnitude of this force will be equal to under root square of the first part plus square of the second part. That means square of 3IL plus square of 4IL, right? That is 9I square L square plus 16I square L square. It will be under root 25I square L square. So what will be the root? It will be 5IL, right? So 5IL is the magnitude of the magnetic force here that is acting on the wire. Okay. So which option will be the correct one? Option number B, 5IL. Okay. Option B is the correct answer. Now the last question is from simple harmonic motion, and the question is the xt graph of a particle performing simple harmonic motion is shown in the figure. The acceleration of the particle at t equals to 2 seconds is, okay. So if we look at this figure, at t equals to 2 seconds, the x is 1, okay. The distance traveled or the displacement is 1, okay. So at t equals to 2 seconds, x is equal to 1, okay. And what is the total time period? It is 8 seconds. T is 8 seconds. So what will be the angular velocity? That is omega. That will be equal to 2 pi by t, okay. That is 2 pi by 8. It can be written as pi by 4, okay. This is omega. Now we have to find out the acceleration at t equals to 2 seconds, and the formula for acceleration is minus omega square x in case of simple harmonic motion. So in place of omega, we'll write pi by 4, okay, minus square of pi by 4. And what is the value of x at t equals to 2 seconds? It is 1, okay. So 1. So the answer will be minus pi square by 16, and the unit is meter per second square for acceleration. That means option C will be the correct answer, okay. So here we complete all the physics questions from NEET 2023 paper. We'll be back with another session soon. Till then, keep learning, keep scoring high. For a better understanding, I would suggest you to practice same questions from our website www.examsnet.com. And for more information, you can download our app